Can I start, Ravi?
Yes, please.
Yeah, hi everyone, people who joined across the globe. Yeah, today we are going to start the concepts called cryptography. So we'll discuss all the concepts which are using cryptography in MuleSoft, and where we need to exactly use the cryptography and all those things. We will discuss more detail about all the concepts. This is our agenda today. Yeah, this is our speakers who are organizing our Hyderabad meetup leaders, Ravi, Shravan, Ravinder, Santosh, and Bharat. Yeah, this is about the safe harbor statement. Both the speaker and host are organizing this meetup up in individual capacity only. We are not representing our companies here. This presentation is strictly for learning purpose only. Organizer, presenter don't hold any responsibility. That same solution will work for our business requirement also. This presentation is not meant for any promotional activities, and yeah, this meeting is will be recorded and will be shared after this meetup is completed. Yeah, today myself, I'm Sai Krishna, currently working as a one single you. That's about me. Let's jump into the concepts about the cryptography and what is the capabilities in MuleSoft. First of all, what is cryptography? Yeah, today's world is digitalization is increasing very rapidly, and parallelly the security is also major cons when you are developing any of the enterprise application. So this comes the cryptography concepts in our application. So cryptography is basically the science of technology using some mathematical algorithms, which is encrypting your payload, so that third people cannot interfere in our communication and cannot see what are the data you are sending. So we'll learn what are the things which are using in cryptography. Basically, it's like a using of mathematical algorithms. For securing it's a set of algorithms and the techniques to ensure our message communication. And yeah, this is a slide I was more interested because see, prevention is better than cure. Why I kept this slide is like when you go out of the home, you will take necessary security steps when you're going out of the home. Like you take all the necessary. Same thing if you come into the software world, you develop any of the application and you are releasing this into the outside world. So if anything happens once you release, once you release means it's out of your hands. So if anything happens, then you need to go and check the issue what is happened. I'm talking more about the security concept. And see because once if issues happen, it is very hard to fix it. Before going to release, if you do necessary conditions to ensure your security mechanisms, that is again the that's the apt for this slide. Prevention is more than better than cure. So that's what we learn how to before using some securities using cryptography. So this is the slide, simple slide. So Elias is talking with Pop. Is there two people is communicating each other over the internet. So like Elias is sending some information to Bob. So like third people like Eve is trying to see his communication. So how better you encrypt your message and to send the Bob. So that is about the securing of your communication. And one more thing more, people will get confused, like security is not confined for one layer. If you developing any of the enterprise application, security comes from your network level to down level, like you encrypt the security property, so it will be not in the one layer. So HTTPS TLS is that's again the network level. So why where we use exactly cryptography is like we will use the cryptography in the data level. So whenever you want to have the some data encryptions and digital signature, you will use this term more familiar in the software development things like digital signings and cryptography encryptions and all. So this is more about the securing of your communication using some set of standard protocols. We'll learn what are the things available in cryptography. So luckily, cryptography is not confined from MuleSoft. It's a universal. Is irrespective of the technology you are using, the cryptography will be can be developed in any of the language. So luckily, MuleSoft also taken this cryptography in our MuleSoft Anypoint Studio. So it is not. predefined component, proper component you will be see in the mule palette. So you need to go and exchange, go type it crypto, you'll see it and you need to download it. And the modules available in the cryptography things in MuleSoft is like PGP, JC, XML, and checksum. Checksum is more about the hashing. Hashings we learn it. Digital signings you use hashing. Hashing we'll learn all those things. Uh, yeah, first we'll go with the JC encryption. And what I'll do is like first I'll complete some slides and I'll show some live demo and I'll go with PGP and XML because if I complete completely in the long stretch, so you'll miss some concepts. So I will complete first JC and checksum and we'll show some live scenarios what we discuss in the slides. And you have any questions, you can ask me in the chat box. I'll happy to answer your questions. So JC encryptions comes to two flavors, password-based encryption and key-based encryption. So key-based encryption will do encryptions and decryptions using some digital certificates. We will use it. Password-based, this is about the password-based encryption. So what basically we'll do using cryptography, using JC or PGP, whatever the component we are using, we will encrypt the message. You send some hello, we will encrypt that message with some algorithm. What are the algorithms you will see here using some password. So the message will be received to the like receiver side. Then receiver need to decrypt the same algorithm with same password. Then only you can see what is the message what you send. That's called hello. So if we cannot see the, if we don't have that password or same algorithm what you are encrypting, like third people cannot interfere your communication. That's about the sending, transforming you message from other party. You will securely encrypt the message and send to the thing. This is straight away encrypt and password using algorithm. You don't have more configurations. It is less secure because people who have the password with them, like third people, they can able to easily get your message of your communication, your payload, basically your payload, whichever you are sending through API to API call, payload can able to see it. So that's about basically people will get confused like encryptions and signing. So what one thing we need to clear about is like encryptions more will tell you about the confidentiality. So who are people who are sending some API request to other people. So your payload structure or whatever your data request structure cannot be see any of the third people. Then only concept we need to do is like we need to encrypt the message. Signing is other party. Signing is like whenever you're sending some message, other people just validate whether this message is coming from this person or any other person just send this message. Signing is about the authenticity, just authorizing, like API kit router, you just authorize the message. If you are not able to authorize, then you throw the error like 404, like digital signing is the other side, encryption is this side. Encryption is more about the confidentiality, like no one people cannot see your request. Using some encryption and decryption you can achieve it. Digital signing is more about the authenticity, the people who are coming the authenticate with the digital signing or not. We'll see all those things in the next slide. This is about the in JC encrypt. We have two concepts, and JC is about the Java cryptography extension. This is developed by this Sun Java library model. Basically, it will run all these JC encryptions and all will run on the Java flavors. In JC encrypt, we have two flavors, symmetric encryption and asymmetric encryption. So we need to clear more about these terms because symmetric and asymmetric, in the technical terms, you will hear more. Everywhere you go, you'll see these terms, symmetric and asymmetric. Asymmetric, other term we'll call as a public key and cryptography, and we can call it as asymmetric. But symmetric, we'll call it a single term, is a symmetric. Symmetric is basically like A is talking with B. A and B will generate some secret key that's called session key will be generated by two parties of understanding using some AES and some algorithms we need to provide to create the session key. And that session key will be shared by two parties, A and B. Now I'm sending the request to A. some message hello. I need to encrypt the message using the session key which is generated by both A and B using some algorithm. That's AES, Blowfish, and these are the symmetric algorithms we need to provide. And I'm sending the request to that's like an encrypted message I will send to the party B, and party B need to decrypt using same session key because we both will share this session key. Like we by understanding of two people will share this session key and will generate it, and two session same session key will be shared by A and B, and B will be decrypted with same session key which is sending the encrypted message, and who are having this session key they can able to decrypt. That's why it's less secure because people who can have this session key they can tamper your communication. So in the real scenarios symmetric is like a less secure because single session key is used by two parties. Asymmetric is somewhat different. Bob is talking with allies. So what Bob will send, and we need to have these concepts called digital certificates. So people who work with closely with any of the these security parts, they can have these concepts called digital signatures, digital certificates. Any certificates will have three things. In certificate chain, we'll call it certificate chain. So three things will be in, under the umbrella of digital certificate. And we have two things here, CA authority certificate and self-signed certificate. And like we people will confuse what is difference between self-signed certificate and the digital and the CA authority. So we need to understand the concepts called is CRT is the some organization will give the certificates to the entities like who are the people having to develop this security part. Like if you develop our own, that's called self-signed certificate. Let's go if you go to any of the bank and you if you want to open any of the account. So if you give your self-signed some ID proof, bank won't allow to open that ID proof. So bank will allow only some other proof and other PAN card because again that's again the C authority because bank trust not you. Bank trust some government issued ID proof. Same thing. If your two clients is communicating each other, so client will not trust you. Client will trust C authority. That's the difference between self-signed certificate and the C authority certificate. C authority is the one organization will give the digital certificate. So people won't trust you generated your self-signed certificate. People trust some entities like in the market we have GoDaddy and Verizon and this of the DigiSat. These are the companies will issue digital certificate. And comes to our part, so we have three things. We let's forget our certificate. We have two things: public key and private key. And I will share my public key to A because I'm the B now. A is sending my message to me, and I will share my public key to get the message using my public key. I'll the message will be sent and received to me. And from once the message received to me, I need to decrypt the message using my private key. And my private key I didn't share to anyone because that's again the security. Anywhere, any situations, we should not share our private keys. Private key should be kept us, and public key should be sent shared to our same thing. If you are unable to decrypt the message using the private key, then somewhere your private key and public key somewhere it's mismatches. People maybe Bob is sending with wrong private key because anywhere universal in one chain will have only private key and public key. They don't have one public key with many private keys or one private key with many public keys. Anywhere we will have only two sets. In one set we will have only always public key and private key is a unique. So that's again secure communication. If you see this diagram, who people who get your session key, they can able to track your communication. This is more secure because people who are having this public key they can able to send the message, and people who have the private key, they can able to receive the message. So this is about the key store explorer. Am I audible, Ravi? Is it fine, Ravi?
Yes. Yes, sir.
Yeah. Okay. Yeah. This is we have widely using Keystore. Again, Keystore Explorer is the tool will generate only self-signed certificate. We don't have access for CA other. CA other again the company like you should issue the certificate. Again, where we should use self-signed means within your organization you are using any of the some logics or and any of the encryptions. You need to use some self-signed certificate, and you are going outside your boundary, then you need to purchase some CRRTs. That's the difference. So as of now, as a demo purpose, I'm using self-signed certificate. Keystore Explorer is a one of the tool. That is the tool because you don't need to run any of the commands. And if you want to run the commands, you need to go for OpenSSL or Keytool Explorer, Keytool command. You need to use it because JDK flavor. It will run top of the JDK. So Keystore Explorer is the thing. We This is the UI based. So if you want to first slide is like you need to go generate key pair. It will ask the algorithm which of the algorithm you need to use it. RSA, DSA, and EC. RSA is the algorithm. You need to click it, and you need to generate the. You will ask some company name, email ID. These are the some specifications it will ask. That's it. You need to create the digital certificate will be created, and in the digital certificate you'll have private key, public key. That's it. And people will have got confused is like what is the key size. So in the digital certificates you'll have the key size. See, basically key size is what we'll use like in the encryption process is all about the mathematical calculations it will generate to encrypt your message. So if your key size is 2048, internally in the algorithm background, so it will use that many number of key combinations to encrypt your message. So so what we need to understand is like if your key size is more, then your encryption is strong because internally it will use that many number of combinations to encrypt your message. And one more thing, one con is like if your key size is increasing, your encryption time will get more because it the message internally. So we need to keep in mind if key size is less, your encryption will be fast, but it is less secure. And if a key size is more, encryption is more secure, but the fast of encryption will be less. That's the thing. That's the concepts we need to use key size. And here, what's the difference between session key? That's a symmetric and here symmetric. In the symmetric keys or the session keys, the key size will be less. See, if we see this diagram, AES, this is the symmetric key generation. That's like a session key. So key size will be always less. So that's why it's less secure. Here always starts with 512 bits of key size. So this is our Mule configurations, GC configurations you'll able to see. Here you need to provide the algorithm, which are the algorithm RSA, which are the algorithm you kept for your key generation. That's algorithm we need to give it. Here you have global element. In the JC configuration, you're able to see the global element. In the global element, you need to add your key store. Key store is again basically even I also get confused initially when I developing these concepts. What is again the key store? Basically key store is about the vault means you generate some private key and public key. You should not keep your private key and public key in your SRC main resources without any security, without keeping any password. Anyone people hack your system, go and open your jar file, they can able to get your private key and public key. So because of that, this is about the concepts called key stores. So it is what you can keep all your private keys and public keys like a bank locker. In the locker, you will keep your what are the money you want to keep it. Same thing here, money is like keys and locker is about the key store. And every locker will have some password. Same thing if you want to you open your private key or private key in our what are the key you generated, In our SRC main resource, you will keep it that key store. If you want to pick that key, first you need to open that key store lock in, and then it will happen in the runtime. So the process will. So that is the reason you need to provide your password. This password is basically the key store password. So that's again the locker password you need to open. Once the locker password is able to open this component of Mule component, then if it is able to get the private key. Using that private key, it will encrypt the message. That's the concept will behind run in the background in the runtime. So this is about the configurations you need to add it, key ID you need to add it here. Again, we need to declare, is it asymmetric encryption or symmetric encryption? If you click the plus symbol, you will able to get it two things, asymmetric or symmetric. Which of the mechanism we are going to provide using this JC, we need to give. Here, if you see this diagram, I am giving asymmetric key info. That's again the asymmetric configure. Asymmetric encryption I am going it. Here you will get two things, symmetric and asymmetric is the two flavors. And what is this key ID? So what are the things you define in the global element? You are just calling here. That's the key ID. So public 123, and you need to define this side. This configuration will be called here. And private 123, if you define, it will pick the private key. Basically, in the encryption process, we'll use always public keys. Decryption process will always use private key. That's the difference. Anywhere you need to use in the encryption process public keys. In the decryption process, you need to use private. It will look like a same TLS SSL configuration, but again that will happen in the network level. This will happen in the data level within our API to API communication. Yeah, any questions? JC configuration. Okay, fine. If you have any questions, you can ask me.
As of now, we don't have.
Yeah, yeah.
If anyone has, please text here. We are ready to answer.
Yeah, checksum is one of the feature available in the Mule component. Mule, not only Mule, anywhere it's a universe. What are the concepts? What we are discussing here is not confined for Mule. Anywhere you work with cross-related, you will come this concepts. Checksum again hashing. Hashing is basically you give some input message. That input message will be converted into the hexadecimal format of fixed length using some algorithm. That's a hashing algorithm. Hashing algorithm basically SHA-256, MD5, CRC32. These are the hashing algorithm. Hashing is basically, and one more thing we need to keep is like reverse hashing cannot be done. How we do encryption and decryption, we cannot do hashing and dehashing. Dehashing cannot be do. Hashing can only be valid as I told. You can implement like a validate check like that. You say I'm sending hello to using some hash value to B only can check it using some validate checksum whether this correct value using some hello or not. So they cannot decrypt completely within reverse hashing. So I'll show in the demo how to do this concept thing. But hashing is more basically calculating the payload into the hexadecimal format using some hash algorithm. Hash algorithm is like mostly we'll use SHA. SHA will be used SHA-256, PyTOL, and all the different hashing algorithm will be used. And technically, we'll call as a digest value. Digest value is also the hashing value. And moreover, this is what we are showing here is a component level. And data view also can have the flavor using the hashing value. If you want to implement your hashing value using some data view model, you can implement using a crypto data view using this. You need to import DWI colon crypto. I import model. You need to add it, and you need to have is a hash algorithm. You need to provide. That's it. Your payload will be, and always hash value will be in the fixed length. You give hello, and you convert using hash value. Everywhere the output will be always constant. You until unless you change some input value the output, but in the encryption every output will be get differ because internally that many number of different combinations will be. every encryption value will be different. If you click it, the encryption value will be different, and that encrypted value can be only decrypted. But hash value, it cannot be reverse dehashing cannot be done. It's only validate. So digital signing, this is also one of the important concepts we need to, like, as a technical people, we need to have the idea about digital signing. Digital signing is more about the first, again, this is a different concept. So encryption and decryption done by, I'm doing some encryption, I'll encrypt using public key of the receivers. But here in the digital signing, what I'll do is, like, I'm sending a message to B. I will use the digital signing using my private key. I won't ask any of the public key of other people. I will only digital signing using my private key, and I will send the digital signature to B. B, I will share my public key to the B. B can only validate. Validate means he will check it whether digital signature is correct or not. How he can be checked using my public key. So encryption, B will be send his public key. I will encrypt it to B, and B will be decrypted using private key. Here it's a reverse process. I will sending some digital signature to B. Straight away, I will do the digital signature with my private key, and I'll send to B. And B will be validated using my public key, because I will share my public key to the B. So this is some technical concept, high level things, what is happening, digital verification. So first thing, I'm sending hello. Hello will be first hashing using some hash algorithm, and one more thing, digital signing cannot be done, can won't be done within direct message. So first internally it will convert hash, what we discussed in the previous slides. So hash value it will generate using some hash algorithm of our message. Then that hash value will be encrypted internally using my private key. So that's called the digital signature. Anywhere you hear the concept called digital signature, first it will convert into the hash value, that's like hexadecimal value, and that hexadecimal value will be converted or encrypted using my private key. That's a digital signature, and that digital signature sent to the who are sending your message to the other party. You need to send that digital signature. Again, you need to send your public key offline. Offline means you need to send, because they need to validate, because because some people have a tampered ever comment. How can you able to know, like, it's like a how you do, like, APA manager, you do all OAuth authentications and JW tokens. This is also same thing conceptual. Whether the message is coming from the like intended user, or any of the third party people have like hackers message and send to your message. So if you send the digital signature, so receiver side, they will validate it. First, the message is coming from the sender A or not, using some digital signature validation. If we are able to validate it properly, then only he will allow inside of our API. That's about the digital. That's the concepts we'll use digital signature. So to authenticity or check of your incoming user, we'll use the verification process in the receiver side. Receiver side, first. They will generate the hash value, and your digital signing will be decrypted using your public key, because I'll share my public key. If two hash values will be same, then he can able to check that okay, my message is coming from my partner only. That's able to, he can check it. So if he cannot able to these two hash values is not equal, then someone has tampered our message. So that's about the thing. I'll stop here, because I continuously tell the slide, so it will be get. So first I'll complete this concepts in the live part. So and I'll continue the PGP part. So if you have any questions,
We have a question.
why they are encrypted here with private key and decrypted with public key? So, yeah, Neha, as I discussed, so encryption is always done by partners public key, not with private key. So, private keys will be always using from the sender's digital signatures only. So, whenever you're doing encryptions, you need to first ask the partner public key. Using that public key, you need to and send to the partner, and partner can decrypt using his private key, because private key will be there his side. So that's why you cannot do encryptions using your private keys. You got it? Okay. Yeah, I'll show it demo now. It can be clear more. So Keystore Explorer, we'll discuss Keystore Explorer as we discussed in the slides. So this is the thing. Go file new, go JKS, store and JCKS is a Java crypto. And one more thing we need to clear is like asymmetric encryption can be how the extension. This is all about the extensions we are using. Asymmetric will support PKCS toll and GKS, and JCKS will support only symmetric encryption. That's again the session key. When you want to create any session keys for a symmetric type of encryption, you need to use JCKS. If you are using JKS, you cannot be possible. That's one of the thing I observed when I'm using this concept. So see, generate key pair. So here, see, generate key, I'm using JKS. So if you want to use JCKS, then you will able to get it. That's the difference. So JCKS is comes with asymmetric encryption. PKCS toll and JKS comes with asymmetric. So you need to just create the generate key pair. So here you need to, as we discussed in the slides, if your key size is big, then your encryption mechanism is more, but your encryption time is less. That's the difference between here key size. So it's again up to you, your business use case. What are the key size you want to define for your encryption? Just click it, and they will ask you some common name and all those things. And you need to give your organization, because we are generating self-signed certificate. So in the CA authority, they will take your all details from you, and they will create some digital CA. So here is again the self sign. So is again the alias. I'll discuss what is alias, where which scenario we need to use, because this is more important. People will skip this one alias, but this concept, the conceptual wise, is more important. So this is again password. See, this is again the password. You need to keep it for our private key. So securing of your vault, you need to create. So if you see here, here you will get three things. Certificate is about your details, what your things you created and all those things, it will be there. So private key and public key. So this is the two things. Everywhere digital certificate will have these two things. And here I'm generating secret key. So these are the set of algorithms. If you remember the concepts called security, when you are encrypting the property files using some secure colon. These are the concepts they are using here. So security placeholders are security property encryptions using symmetric encryption. So you will use see these concepts called blowfish, AES. So because there the concepts they are using is symmetric encryption for our security properties of so AES, as we discussed, the key size is small. If your key size is small, then your security is less secure, because that many number of combinations like a hacker can able to get it. That's the less secure. How you develop, other people can able to track it. That's if your key size is big, eternally algorithms combination size is very big. It will take some time to uh, get your hack message and all, because that's why it's less secure. Symmetric encryption is again I'm going in the conceptual level. In which scenario we need to use symmetric and asymmetric, again it's up to you. Your encryption process want to be very fast, because it is in less common, it will be very fast. With asymmetric, your encryptions will be take some time. So your again the process, your performance and all will get reduced in the thing. There will be pros and cons to which scenario you need to go it. So that's the different. That's the creation of the things. Once you create it, then you need to just save it somewhere in our folder. I and just copy paste in our SRC main resource folder. I am created here. This is my JKS. So I'm coming with the first JC. So this encrypt. See, this is the thing I'm using. Mulesoft.jk. So this file I'm calling from the src main resource folder under the crypt folder. I'm calling it. So .jks, which type of file you created? Here in the things you can be only do with GC case, piece cases, and GC case. PEM files and all we cannot be using here in the Mule. PEM files and all other technology people can able to pass it, PEM files and all those things. But here PEM files and JKS and algorithm. This algorithm is about the this key store algorithm. As we discussed, is again the bank locker locker. Inside the locker, you'll have some private key. Within the locker, you'll have private key and public key. So this is again the locker password of our vault. It's again the .jks folder. So again, if you click here, I will have two things, asymmetric and symmetric. So which type of encryption you want to go with? I'm going with asymmetric encryption. So I'm giving it private 123. Again, I'm because here is a demo purpose. I use two things here, but in the real time when you are implementing, there will be because I'm doing encryption or decryption only. I use some private. Other party will use only the private. Here for the demo purpose, I use both things in a single configuration. So that's why it will be get two things here. So I'm using public 123. Public 123 is like I'm just referring the public 123 of this key. So which where we need to provide? We need to provide here go and we need to provide the this is like referencing the public key from the global element. So if you give private 123, then it will be picked from our private 123. This is the key ID. Key ID is only the referencing of which key you are picking from the JKS key store. So that's about the keys. And one more thing we need to clear is like passwords will be there only for the private keys. Public keys we don't have any passwords. It's because we will share the public keys to the sender side, right, like our partners. So no need to keep any basically we don't need to keep any passwords for the public keys. Private keys will be needed for the passwords because decryptions will be done using private keys. If you have your private key without any password, anyone have the access get your private key, they can able to decrypt or can able to get your message within the communication process from A to B. That's why we need to keep it some passwords. So that's the here concept. Algorithm we need to define which algorithm and all. Cipher is again the more technical things is like paddings will be used PKCS paddings mode and all those things. Padding is basically is a more secure. You send hello message without sending hello plain hello. Use some padding. Padding is means using some nonsense data. It will add it in the before encryption. Hello, it will add some random nonsense of data using some padding type outer layer it will add it to hello using that nonsense data plus hello it will encrypt. So like who are able to decrypt or hack your message, they cannot able to get what is exact algorithm because you done some random nonsense of padding. So it can be only using some decrypt using some paddings. Which are the padding you define? If you give in the decryption process, first it will take that nonsense data, then it will use the decryption process. That's the padding. Padding is basically adding some nonsense data to your hello message before encryption process. That's the thing. Key ID again. Here see I'm using encryption using public key. In the decryptions I'm using uh, private key. That's the difference. And checksum is more straightforward. You don't need to use anything, just hash value and the content. That's it. And validate checksum. So the algorithm which you are going to hashing, that algorithm you need to pass. And payload. I'm sending hello and some hash value. You need to provide both things, your message and your checksum value. So if you're able to validate it, then it will allow to the next component. It's not decrypting. It will checking whether the hash value is correct or not. is basically what you will use the tokens to check whether this token is valid or not. Same thing here, you will check it and you will send the next component. So that's the concept here. uh, Data view, we can use the data view here. I'm showing the data view concepts I'm using, and the simple logic I use it here is like in the JC. And one more thing, yeah, I forgot to show. This is about the password based algorithm. So password based I showed, right, in the slides what I showed in the previous slide. So you will have only two things: password and algorithm. So you don't use any private keys, public keys, and all those things. Straight away, algorithm, password. This is less secure. See, because anyone able to get this password and algorithm and like able to see our things. So we are not using any of the keys and all those things, digital keys. So this done here. And one of the logic are implemented is I'll show in the thing in the demo. So encrypt, one of the logic I observed in the using JC, some people have the requirement like some key values I need to encrypt. I don't want to totally encrypt the total payload. Only like masking. Some people have the requirement. Some sensitive information of the customers. If you are working with any of the sensitive information, like account numbers should not visible. You need to mask it or you need to encrypt the message. Rather than encrypting total payload, I need only key value need to be encrypted. So these are the logic implemented for that requirement is like uh, you use some lookup functions. For again, the lookup function cannot be implemented using subflows. It can be implemented using flows. This is again the subflows. Without source subflow it won't be there. It cannot be implement lookup. Use this lookup function using in that. You implement some function. In the function, you call this lookup encrypted flow, that flow. Wherever you want to encrypt, just call that function. In the function, it will call the lookup, and total encryption will be applied for this field. Wherever field, if you want to apply city to encrypt, use the encrypt function here. Internally, it will call the lookup function of the encrypts the total mechanism, and the city will be encrypted. And the decryption also same reverse. Decryption, you need to implement that. You need to call the decrypt flow using sub lookup function, and the decrypted payload will be. See, I'm just sending it, and here I'm sending to the. If you want to see the credit number, because when you are transferring some sensitive information from within the API to API or the internet, how the requirement no like credit card numbers and all need to be. And one more thing, masking is about the hashing. If you do masking, like receiver cannot able to get the credit number. Again, that's one of the challenge. If you do some masking, maskings can be done, can be achieved in the loggings. You can able to implement these concepts. But if you do here masking, reverse masking cannot be done. Masking is about the hashings. It cannot be done. That's why you need to try to implement this of the function. So I'm just able to get the grade. If I miss any some number, I cannot able to get it. If someone has changed the payload, so because the decryption cannot be able to implement. If I want to get it, I need to get the correct value. If it's change, because try to people get some changing in the communication and all. So try to implement. This is the logic. I just tried it. I got some idea and tried it. This functionality. That's it. And password based we discuss. Checksums we checksum and it password based is straightforward. JC password, so no need to try because I kept two component in the single thing, encrypt and PPA. That's why it's able to get it in the single thing. We don't have much complexity here. And checksum, this is the pass and symmetric encryption. Symmetric encryption is because symmetric encryption your payload will be less small because using so small keys. So symmetric encryption is also same. Just need to pass your symmetric keys here. This is the symmetric encryption. JC symmetric. Symmetric encryption, you need to use JCE case as I discussed because it's not supported with JKS and PKCS12. You need to go with only JCE case and you need to view your key. And same key we need to use for both sides. We don't have private key and public key. So those are the things here in the symmetric encryption. And checksum here, calculate the value. This is the hexadecimal value, a hash value. And this value we need to send in the header level. This is the logic I implemented here in the checksum. Once the sender party sends some checksum value, they need to pass it in the header value. So in the headers, I just kept in the say headers dot checksum, and I'm passing here in the expected value. If this payload value of the same checksum hash value is same, then only it will get validated. So it's again the check. See, it's about if I change some value, it will throw some error. You need to get this type of implementations before kit router and all. This is about the validations. Here if I get it some actual value, I will able to get it. That's it's like checking. It's not about the decryptions. uh, this is the concept. I am forgot to show signings, digital signings. So digital signings is more about here digital signings is also same. We need to use private keys, and using this algorithm, first it will calculate the hash value, and that hash value will be encrypted using this private key. That's the process it will follow internally. So why this algorithm is like it's a hashing algorithm. Using this hashing algorithm, first it will convert hash value. Again, hash value is the checksum value. This is the using this value, it will encrypt the message using the private internal process. It will go inside of your algorithm. So this value, same thing, checksum and digital signature is same. This is the digital signature. This is the digital signature content. Digital signature, people will send in the here I kept roughly, but you can frame it some data, you some give some good naming conventions and you can give it. And digital signature I'm passing here in the header level with same message. What are the message I'm sending? For this message I'm sending some digital signature. If any of the value changes, it will get error. We see I'm changing some value. For this value, the digital signature is different. 1 minute, I need to change here. So if I change it some value, the digital signature will get failed. The last unit, you get some value, it will get, you pass some any other value, it will get not able to get digital signature verification failed. For this value, it will get same value, the digital signature will get changes. That's the concept. So that means whenever you are sending some receiving some message, every value you are checking. Once the message like API request is received to the receiver side, every request you are checking with using some digital signature. If the digital signature of the particular payload is not matched, then you can see that someone has tracked your communication in between. That's the thing. Yeah, these are the concepts. Any questions you have? Okay, I'll go for PGP. PGP. Okay, yeah. PGP is like a pretty good privacy encryption. Pretty good privacy is like a, this is again the different flavor from JC. JC is somewhat different and PGP is somewhat different. PGP comes with two extensions, GPG and PGP. So here also we'll use two things, public key and private key. And we use, this is technically will is a more complex, and it's a hybrid because in JCE we use two things, symmetric and asymmetric. In PGP, we'll use hybrid. Internally, we'll use symmetric and asymmetric thing, and we don't have PGP with password based and key based. We will have only the key based encryptions is possible with the PGP. And one more thing, people will ask these questions like, what is the difference between PGP cryptography and JC cryptography? So one thing we need to understand clearly is PGP comes with extra benefit, like it will encrypt the message, and once the encrypt the message, it will compress means when you are sending some payloads to the receiver, so before sending it, encrypted message will be compressed and will send to the receiver. Using this, the transmission rate will be very fast, because you are always compressing the payload of encrypted. And one more thing, uh, it's a it's very fast. And when you are using some big payloads to encrypt, GC cannot able to sustain. I tried it. Big payloads, it cannot be able to handle, because again the size factor. PGP, you can give whatever the size, it can able to encrypt the message. So like keep it in mind when you are doing some encryptions, which flavor I need to go, using JC or PGP. In your requirement, you have some big payloads to encrypt, then go for PGP, because PGP is lightweight, and our transmission rate is also good. And compared to it's a hybrid, it'll have a higher security. We'll see this thing. Uh, Plain text is encrypted. Again, this is a hybrid. You'll have symmetric and asymmetric. Two flavors will be there in the single PGP. There it's a concepts we need to implement. Again, session key is like symmetric key. First, PGP will generate private key and a session key in the hybrid mode. First, the session key will be generated. The session key, using the session key, data will be encrypted. Then the job is done. The encrypted part is done. But that, what are the key you are using the session key, that session key will be encrypted using the receiver public key. So when you are sending some message to the receiver, so you are sending some encrypted data and you are sending the encrypted session key. Two things will be get binded and will be thrown to the receiver side. From the receiver side, first, if you want to decrypt the message, he need to get or she need to get the session key. If you want to get the session key, then they need to decrypt the session key using the private key of the receiver, because receiver already shared his public key. Using that public key only, the session key is encrypted. If you want to get the session key first need to decrypt using the private key. Private key will be kept in the receiver side. So that's again this hybrid model. Data will be encrypted using session key, and the session key is encrypted using asymmetric port, using private key and public key. So once the session key is able to get from the receiver side, then he can able to get the message, what are the things. This is the creation of PGP key pair. We have two flavors. This is like a Cleopatra is one of the tool you can try it, or you can try it git bash. Git bash is the tool you can generate in the command base. So Cleopatra you can generate, there you use keystore explorer, here using Cleopatra is one of the tool. And git bash commands, because JCE is separate thing, it will run on the Java base. PGP is again the separate. Creation of the keys is also different. So what are the keys you are using in the JCE cannot be used in the PGP. Big PGP is comes with the combination of a GPG and PGP. That's again the, you need to provide the command using some mail ID and password and all those things you need to use. This is the configurations you need to give it in the, see this is the algorithm I'll show in the demo. So this is the thing. I'll close it. So Cleopatra, you can download it. Cleopatra is one of the tool to generate. So or you can use git bash commands. I'll give git bash commands to get it. If you want to try it, you can try it. And you can. Uh, I'm just using Cleopatra for time being. I'm using Cleopatra. So see Cleopatra. So just need to create file new key pair. This is the again see this is the C authority. We are going normal. You need to give the your email ID. Just you need to create the email ID. Create. Just finish. So every key will have some fingerprint. Fingerprint is again the same thing. Here is a password. It's not password, alias. So one thing I forgot to tell what is the use of alias is very important. You need to get the concepts called alias. So here using called alias. Alias is the term you use here. So this is alias. So alias is like a every key will have alias. You will have some requirement. I have 10 keys. I need to implement 10 encryptions. 10 encryption. Rather than creating keeping all 10 keys separate, it's again the it's not good practice to develop all 10 keys here keeping SRC main resource calling. You keep all 10 keys in the vault, or you can keep all 10 keys in the security vault, and you pick that file using alias, because every key will have different alias. You can implement this logic, if else logic. If this if this condition comes, I need to pick that key using some alias. You pass the alias name, that key will be picked using that 10 keys. 1 2 3 4 10 keys will be there. It's like a customizing of your folders. You have 100 keys, you need to implement 100 encryptions. It's not good practice keep 100 keys you are calling. Rather than just you use the implementation if else condition. If the condition payload dot condition equal to a, I need to pick the alias. If you give the alias, automatically that key will be picked because you keep all 100 keys in the single vault. That's the advantage. You need to use it using alias. So again, the customization and the requirement comes, it will be useful alias. So also same thing, fingerprint, every key fingerprint will be different. Same thing, alias. You have 100 keys, 100 fingerprints will be there. Which alias you need to call it, same thing, which fingerprint you need to call it. It's again 100 keys you can keep in the single keep it. So that's the advantage. So I'm just using PGP here. PGP here it comes with algorithm. This is the session key generation, symmetric algorithm to use encryption. So using this algorithm, first it will calculate the session key, and using that session key, first data will be encrypted. The job is done. Then it that the session key should not be sent plain. This session key will be generated by machine. The component will be generated randomly. So because we are not generating here in the JC, we are manually generating session key and shared by two parties. Here in the PGP, the machine will generate the session key using whatever the algorithm we need to pass. But in the decryption side, he need to get the session key. If we want to get the in that the session key will be transferred in the receiver side, but he cannot able to see because it's an encrypted format. For that, he need to decrypt using the private key of the receiver side. If you want, he will get the session key, and using the session key he will able to decrypt the message, because using the session key only will encrypt that message. If you want to decrypt, first we need to get the session key. This again, session key encryption we are using asymmetric encryption, and the data level they are using symmetric encryption. That's why it's a combination of both symmetric and that's why we'll technically we'll call as a hybrid encryption. So I'm just hitting encrypt. See, encrypted message. So decrypted message. If you if you change any value, you can able to we cannot able to decrypt. So it's a 500 server because component cannot able to decrypt it. That's again the first you need to get the session. It will have all those things. I think it will be in the base 64 encoded. The component first decode base 64. It will get the encrypted session key. the encrypted session key first will be decrypted, private key and all. Internally, the logics will be applied. So I tried simple mechanism forever. What is the use of this cryptography is like you can implement some custom type of policies. This like you pleasure to implement all some ready-made type of policies. So you can try to implement using some custom level securities. So as is showed, see this is a payload. So I'm encrypted using my public key, using the receiver public key. This complete message I'm sending in the payload. So in the receiver side, first they need to decrypt this message. If we cannot able to decrypt the message before API kit router, it will throw an error. So see, I'm just the authentication is invalid. This is one of the custom policy you can try to implement using some cryptography. So if you able to send the correct message, then only you process to the next internally in your API kit router you just allow. If you didn't able to decrypt or anything, just throw the error. Authentic is invalid because someone has changed your message, so you just throw the error. So that's the concepts we can use it for our custom type of securities and all those things. So this is all about the PGP. Any questions you have? Last slide will complete in the XML within 5 minutes. You have any questions you can ask me. No question. Okay, I'll go with the XML. XML is right for XML. People will ask like, where you use XML. XML is again the SOAP services you are trying to implement. So you'll have this type of encryption. Same thing here again. We are not using any PGP GPG format. Here only we are using JC, JKS key stores. What you try to create, same keys you are using XML. So same thing. We need to pass it. It's again the hybrid. PGP XML is again the hybrid. First, you'll create the session key using your algorithm, what you are passed, and the session key using session key data is encrypted, and the session key will be encrypted using the receiver public key. It's again the hybrid mode. XML signing. XML signing will be the three concepts. It's again the more complex thing is like it's again the three things will be there in the XML signature signings, digital signings, enveloping, and so what is the difference? So enveloped will have first signed data, inside signed data, like signed data means your message data. Within the signed data, somewhere it will have signature tag. Enveloping first starts with signature. Internally, our message will be fit in somewhere in between. Uh, Internally detached is something will have external reference ID. I'll show in the demo here. So XML cryptography. XML is more about the algorithm. You need to pass it for our session key generation. In XML, you can encrypt total XML, or you can have some specific element you need to encrypt. You can use it element path. So in my payload, I want to encrypt some credit card number. I can able to encrypt the message using some credit card number. So same thing you want to completely XML need to encrypt, just remove. Don't give any element path. It will take complete payload. It will encrypt. So decrypt also same thing. Again decrypt I'm using private key of 123 because my private key I'm using to decrypt. XML signing. Here we have three concepts: uh, enveloping and detached. So what is the envelope? First I'll show encrypted message. So he'll have all this data and cipher data and all those things. So decrypt. So you'll have this message. So if you miss some any value, it will not be decrypted. Here the comes digital signing of enveloping and detached. So first it will start from enveloped. Envelope starts from signed data. Signed data means what are the payload you are trying. So message in between somewhere you will have some signature. That's again the enveloped. So enveloping means it will start from signature. Somewhere it will have in between message. That's the difference. It starts from signature. If it starts from signature, it's a enveloping. Enveloping. It starts from message body. Inside somewhere you'll have some signature. That's like enveloped. So internally detached will have some reference unique because internally detached is like it will separated internally in the XML. The it will be two parts, message and the signing, but two things will be interlinked using some ID, reference ID. Using this reference ID, it will able to sign the message. That's the internally detached. Yeah, this is all about the cryptography concepts using. We'll have 5 minutes. If you have any questions, we'll go for the next quiz and all. Yeah, hi Ravi, I'm done with the.
Yeah, if anyone has any questions, please ask here. I know, um, see, tricky part this topic is that everyone thinks that we know everything, but by the time we close everything again, we get hundreds of questions. Even sometimes it's very difficult to even ask the question. That's what many people face the problem. Yeah, if anyone has any questions.
Yeah, hi Prem, you have any questions to ask? Yeah, thanks, Neha. So you can try to implement some customization. It's not about the encryption and decryptions. Try to implement in the whatever you're trying to implement in your enterprise applications. Try to implement some customizations and all those things. So encryption, decryption is straight away we can do it, but take it some idea using some concepts of cryptography, and you try to implement in your own way. Try any of the scenario or your logic, try to implement. So this is the things I showed here. This is the logics I try to implement. Particular key need to encrypt using some encryptions and all. You can implement, you can try to use some API kit router policy and all those you can try. If you have any questions, you can ask me in my, I think in LinkedIn, you can try to reach me. I'll help you in the cryptography concept.
Yeah. Yes, I mentioned if anyone has any questions,
Yeah. If you
maybe
have
I'll
any
come.
questions, just ask me now. I'm happy to answer the questions. Don't hesitate to. You have small question also, just ask, come and ask me. So it will be. So if we have to communicate each other, it will be clear in the session itself. Can we encrypt the header data? Yeah, we can encrypt the header data. Anything we can encrypt. But I think it's only taking the string data. Someone asked the earlier, is there any data type validations you can see? It's not like that. Some people ask, can be numbers can be encrypted? Yeah, we can try it, but I tried it string type of data. In such scenarios, what we need to do is like convert your payload first to stringified. If you have JSON data, first if you want to encrypt, convert it, try to convert in such scenarios. I didn't face any scenario. If you have any type of data type restrictions, you can convert straight away your JSONs or everything into stringified format using data view write operation. You can try it using that string data. You can do it. You have any such scenarios you are facing, data type restrictions and all, using you try to convert into stringify format. Yeah, Prem, we can do it and keep the header data. You can do header data sense which type of header data. You can do it any type of headers. But basically, what we'll do is like your encrypted data will send in the headers. That's the difference. Whatever the you are sending some encrypted data or your digital signatures, those things will be sent in the header level to the receiver side. And basically, it will happen. Ravi, can we go for the quiz part?
Yes, Sai.
Yeah,
So thank you very much, Sai, for our
yeah,
wonderful session.
yeah,
Let's move on
yeah.
to.
Thanks.
I will stop recording.
Sure.